Cisco location and ID separation protocol. So this is the third part of the VPN. Now what it is exactly. So the router will have the serial number. Now once you have the where you want to put that router, that location will be transferred to the main database, which is the same mechanism as DMVPN. Now it has the same protocol, and like the concept of you are having a main router, okay, in this center, and there you wanna control all of it. So to get the remote access just for the router, this is what this is for, and you will get this part called endpoint identifier. It is same like the PC which you want to enter. You will uh, this is how you're gonna get entered. They have this relocation routing locator where you will know where the router is. So for which location, it's just an ID, the city you're currently in. How LISP work concept on concept method. Now let's go what I was trying to find out. So what does LISP really mean? It is a networking architecture designed to fix the core internet issue, which is IP addresses are currently their identity and their location. The problem it solves right now, an IP address mean who you are, where you are from. Why this became rapid growth for the default free zone? This means global internet routing table keeps getting and bigger. ISP must store millionaire every new add more entries. Routers struggle to scale. So your internet connection when it shows that, imagine the YouTube. Okay, if you're building a website, imagine your local own business where you're trying to host the website in your laptop. You're not gonna be able to receive all of the when someone like me try to enter into your business or into your business account website. I won't be able to get that load the page very quickly, or it will show me that this page might not even exist. This is the issue that it solves on the first try. Separate identity from the location, then the large scale, this is where it's used for. Now this is the part the main important part for the LISP are that these are the words that needs to be understood, which is ingress tunnel router, which is going out, ingress inside, so outside inside, map server keeps mapping database, map resolver, where is this EID. So map server is the record of all the routes, okay, and map resolver is where can I, if someone asks where can I find this router, it will look into the map server. Now when it is used, it's used on SD access on the large campus data center. What is this slide example? If a user familiar, they might need a route changes everywhere. With LISP, user keeps the EID, okay, only RLOC changes. Anyway, what it means is that once I enter into the what is it like called remote access, you need to have the remote access, that's all. What is this slide saying? The internal route become too big. Okay, now once we are done, this is the part of the explanation about the tunnel. Now in here are called are just ITR button for non-LSP site that sends traffic to the EID destination. So person like me will try to go into the site, the which is the location ID. Where I'm trying to get inside to the part where it's SD-WAN is. Tunnel router proxy. It's just a VPN type proxy. Like I'm using another PC to get inside it, and I don't have the ID, so it will ask for my username and password. Then we have the tunnel router to routers that perform ITR and ETR functions. ITR, which is the ingress, and so the router that functions, the router that functions, that is, you know, that is able to that works with the SD-WAN, or it's the router that is the SD-WAN, that's called the ITR and ETR. So well, LISP, the name of it, where LISP routers, which is the, yeah, that's all. Now, big picture first, simple diagram of how things work. Now let's go to the part of this LISP, map who you are, okay? Now this each meaning, I went in more depth of those part. For example, what is an EID? It means who you are, where you are, okay? Then the core idea reminder location. It will ask for your location. Now each term in human language. IP address and with an LISP site, a site the network a campus. It means encapsulate packet from the EID destined outside. What it actually does, device sense ITR look where is this EID located, find the reloc, ingress RD encapsulates, XTR, the router that performs both ITR, ETR, PITR, the one this exists for the compiler. Not every site on earth runs a normal IR series normal non-LISP EID. It receives the attacks. A device sends a packet to the to EID of B local router. Looks at where is that EID, finds remote okay. I'm just showing this part to for you guys to look at what I have seen. If you guys don't feel like this was helpful, you can skip this part. Now, as we talk, map server is where we will find the things. Routing locator is an of ETR, that is internet facing or core facing network. Okay, that perform of any. Okay, proxy refers to the perform router that performs PI. The main thing. Okay, proxy are just like for that sense. Proxy to non-LISP, proxy XT ETR, in getting the ETR. The main thing from here are this part, map server and map resolver. We talked earlier about this, map server and map resolver. So that's all for from here. Then we have the I didn't understood. Okay, so this is the part that I didn't understood. All of it. Routing locator is an IP of ETR internet facing central address. So this is the IP it will go out and come in from. So this is the part of this is the scenario. Okay, putting it all together. Local router, where is 10.1025? Map resolver, it will check. Map server is within the maps MSS. Map the map resolver says map server will says 10 point it's at. Okay, MR since that answer relocation, now you get the connection. Okay, we finish this. Then we head on to the LISP architecture and protocol. So for the routing the how are they made the routes, what do they need to get the connection and the routing going on? So they need two things, endpoint identifiers and the control plane. What is the control plane and what is a data plane? It's many of one of the questions where it's hard to understand this concept. So the best way I could find out was that control plane is where you have the OSPF and BGP. This is the main part I needed to understand control plane. Now the data plane is the data inside it. So is it encrypted? So the whole point of GRE was was encrypting the original IP packets. So that's where it is. ILSP map request, map reply, asking the map resolver. So the OSPF. Now looking to the ingress tunnel. This is the how they want us to visualize that all of this thing nonce instance ID LSPs are in the ISP header, and that ISP header is inside this part. Okay, this inside this space, and the outer LSP header is renamed as source relocator IP address, and then we have the destination IP address. So not really understandable from this part, but we can understand by this the diagram inside it. So first forget the diagram for the normal non this is the part source IP destination IP. So we have the source IP, okay, and the destination IP. Okay, no, we shouldn't be considering that. Okay, destination in the now add LISP into it. Routers on the internet don't know where EID 2.5 lives. Okay, destination 2.25. So what LISP does? LISP does not change the original, wraps the original point to a new output packet inner box. Your PC remote server local router has relocation ID, and the remote router has the relocation ID of 2.2. Step 1 original packet ITR the router SD-WAN I cannot route across the internet. Then ITR wraps that part. Okay, UDP port inside my relocation outer source IP address. This is the outer source IP address. Where is that? Where is it? Where is it? This outer source IP address. Then it has the destination location IP address, UDP source and UDP destination port. Okay, inside it source EID, and that now this is the connection. This will be the this will be wrapped. Okay, 10.1 in here. Okay, it's the for travel across the internet on router only sees the ether, then it's de-encapsulated. After that, the original IP address is shown. Let me say it. That's the entire slide. Okay, and that's all we have. Now, what is the UDP port 43441? IP in IP UDP encapsulation. A full form for it's just a port number used by the LISP. UDP user data monogram. Okay, when LISP encapsulates packet, it needs transport method. So think of it, LISP uses this. Then we have the diagram. Okay, this is the diagram. 10.1 is the EID, then it goes to the DNS. Okay, ingress it will go to the actually to the ITR. Okay, this is the ETR. When things it will be resolved. Okay, just acting like a DNS. It will send a message to the MSN. What is map resolver? A map server, and that map server will send it to the ingress tunnel router. Then it will send it back to the request to the relocation space. They will have the connection now. So that's what we and now this is the part. It is since I have to reply message. Okay, that's what it happens. Then after that, this is the story mode. Hey, I'm looking for host2.com. It says DNS. It will reply with the 10 point. Just read it actually. Plain to your local English. This is going to the router checks it for FIB. It's checking its router FIB in here. Okay. Then it sends out to the map where is EID located. This is called map request. So the map resolver maps are on the same map server and map resolver with router on 10.1. It forwards to the ingress tunnel router. It sends it to here. Then when it's located, hey, this is my address. The EID sends it back to the ITR, to the relocation ID. Okay, your local router, whenever I need to use, send it to the 1.642. This is the 64.22. Whenever I need to reach 1.22 or 1.22, you'll send it to 10.64.22 IP. So this is in one line summary, the whole process. Your PC asks DNS for an IP. Your router doesn't know where is that ID live. Then the LISP asks, system looks it up, and it sends the reply. So that was the diagram. And now we have the ITR receives a packet from the EID step 1. So that's relocation ID. This is what it looks like. 164. This is the source IP, and this the relocation, the outer side IP address. And that's all. Play your this your local device and read them all. So what it's saying is that packets are how packets are wrapped inside the tunnel, how they are talking to each other. So we understood that part. Okay, the ITR puts the into a new envelope, and then before the LSP, after the receives packet from the local ITR, when it receives it unwraps it. That's all. Then the proxy ETR, how does it work? The following steps describe how the proxy ETR process illustrated. Hostnode performs DNS lookup for the cisco.com. It gets a response from the DNS server with an IP address 64.2.2. So step 1 performs a DNS. Okay, it will look for the host.com. It sends to the it will send it to the where is the one 2. It will send to the map server. Then the reply will come with the relocation. Then this part happens. ITR sends a map request to the 254.54. Okay, this is where what it says 64. This is the the location. It sends the locations. Since then when the location, the mapping data responds with a negative map reply that include calculated, prefer to add it on the map. So it adds that this is the non LISP. Okay, you can now, so it still needs to send it. Okay, but it's not a non LISP. It doesn't have any LISP to it. Okay, no, I'm wrong in here. Okay, 1 2 3 4, it will send back to the, yeah, I was right. So since it's not the LISP, okay, it will yani this, that's why I put it in ChatGPT, because I can speak that very well. Okay, step one, Cisco, your computer wants to open cisco.com. It asks DNS, it gets the address. Then the ITR gets the packet, your local English receive packet going to is this LISP address? It sends a question to the map result. Do you have a mapping of this? The comes back, so this, it doesn't have LISP to it. The map result checks the map site and realize this address is not part of the LISP site. This is LISP, this is LISP, but this isn't. So how can it send a request to the, outside the internet? Since it's not an LISP destination, the ITR no. So I cannot send it directly as LISP traffic to ETRs. Okay, proxy egress tunnel router, the ETR encapsulates the data and its own IP address. So so it encapsulates its IP address. So when the proxy egress tunnel router receives, it encapsulates and sends it to the PETR. This is where the, like, pretty cool, right? If the mapping system says no, ITR sends the traffic to PETR, forwards out to the internet, and that's how it's almost like exactly like the NAT. Now the same thing for the ITR. Instead of now what this trying to reach to the from the non-LISP, is trying to reach to the LISP site. Someone on the normal internet, for example, wants to reach the inside the LISP internet, wants to, but normal internet routers don't understand. So before it was ETR, now ITR, proxy Ethernet part. Okay, then you have this part called how it will send the traffic. This packet reaches the, okay, first it goes here, okay, to the proxy Ethernet. That's not where, so it asks the LISP system where is 10.1.1. It will ask the map server where is this site ID. Okay, once it gets the site ID, it sends it back to the PITR. Then the PITR sends it back to the ETR, which is the English tunnel router, and that's how it gets connected. So map checks the server. Okay, it sends the remote connection to the, just read it. The remote router in a replies EID is located at relocation map reply. Then the PIT knows where step 5 how to send it. I must send this traffic. Okay, encapsulates. So in here it gets de-encapsulated. LISP into internet, proxy Ethernet, egress Ethernet router, LISP to internet, internet to the back to the LISP, and then this I added the, a few function from the chat GPT, how things goes, what are the how the map replies, how the mapping system come. Host A sends LISP number 1. Okay, LISP to LISP. Ingress tunnel iter, LISP to LISP, encapsulation, ta. This is the ETR, ITR, mapping solver, Ethernet non. You guys can skip this part, but it's just maybe this the diagram that it's by the ChatGPT is also wrong. But the main concept was the ITR and the ETR, and that's how we finished with the LISP, and then that's how we will finish the LISP concept. Thank you for watching me, and let's go to the next chapter. Virtual extensible local area network.